Guess I don't have it. Figure 1240. I don't have it. I thought I did. Shame on me for not having it. This is example 9.
Example 8.
I'll have it next semester. I would dearly love, now, I've got a point on the plane. I've got a point on the plane, and I've got two lines. No, I've got a point on the plane on the line of intersection of the two, right? But I now need the slope of the line. Ed, what were you saying? I'm sorry.
Is there a general formula for three-dimensional slope, like
Yes,
delta?
yes,
Okay.
yes.
I don't recall what it is.
Well, we're about to back into it right now. Right now. The slope of a plane is what? How do you define the slope of a plane?
By just one plane.
Rise of the run.
The slope of a plane. How do you hold a trowel when you're mixing putty to float a seam? By the handle. The normal unit vector describes the slope. And it isn't even on there. You remember I tell you all the time how strange that is? That normal unit vector is a vector orthogonal or perpendicular to the plane, huh? Let's see now. That's got to fit in somewhere, doesn't it? Any suggestion?
That'd just be the.
I want a vector. I have got to find a vector that is parallel to this line. But that vector that's parallel to this line could be perpendicular to the plane, huh? So what we do is we're going to find here's my idea. A normal vector, those are two planes up there, aren't they? And each one of those planes has got a normal vector, huh? And we know what those normal vectors are by just looking at that equation, do we not? Isn't that the way we form that equation, is with the coefficients of x, y, and z being the normal vector? So I'm going to take the two normal vectors. So I'm going to take a vector that is perpendicular to each of the planes, And then I'm going to find a vector that is perpendicular to both of those vectors that are perpendicular. Does that sound like parallel? Does that sound like parallel? Think about it. Think about it. I've got a plane, and I got a vector that is perpendicular to it. I've got another plane and a vector that's perpendicular to it. Now what I'm going to do is I'm going to find a vector that is, this first vector was roughly like that, was it not? This vector? And let's say this second normal vector is like that. So would you agree my first plane is right here and my second plane is right here? Huh? And what I'm telling you is this vector, now I want to find a vector that is perpendicular to this, the plane formed by these two vectors. Huh? Seth's turn. Seth, I want you to poke that pencil right in that space right there. Right there. You remember here's the first plane, here's the second plane, and I found a vector normal to each one of them, right? And aren't these two planes? Seth, you get one and I'll get one. Hold that paper as straight as you can right there. Do it like that, maybe. And then mine is like that. Now, let's turn it where they can see it. Yeah, just hold that piece of paper. Ah. Now, that's the first plane. This is the second plane. Travis, move over and stand about even with Byers. Can you see it?
Let's see what.
Come around, stand about even with Byers. Can you see what the plane of intersection looks like? Isn't it where my sheet of paper touches Seth's sheet of paper? Y'all go agree? And is that not parallel to the pencil? Mm-hmm. And that's how we're going to do it. Get the idea?
Yeah.
Thank you. Pretty cool, isn't it? So what we're going to do is we're going to find two normal vectors, one for each of those. That's these two pins, right? Then we're going to cross them and we're going to get that pencil that Seth held. And that pencil is going to be perpendicular to these two, right?
The line of intersection of the planes.
And it'll be parallel to the line of intersection of the plane. I'm out of time. We'll do that on Wednesday. Isn't it better when it makes sense?
Oh yeah.